back here for more space conferences with Create and Learn. Very special evening tonight, and we've got one of the best and brightest, I would even say, I can go out on a limb and say best and brightest people at the Jet Propulsion Lab at NASA, a good friend of mine, Marc Rayman. And I'll give you guys a bit of background because I think you may know something about Marc, but Marc is the chief engineer and for missions operations and science at NASA's Jet Propulsion Laboratory. And currently, he's actually the chief engineer of the Psyche mission, which I'm sure we'll talk about a bit tonight. And Psyche is both an asteroid and the name of the mission. Maybe Marc could explain how that came to be later on. So this mission, Psyche, is the first time we're going to be exploring a world that's not made of rock or ice, but metal. And it launched on October 13th and is scheduled to reach Psyche sometime in July 2029. Is that still correct, Marc?
It is.
Okay, great. Marc grew up in Toledo, Ohio, studied physics at Princeton University, and he did undergraduate work in astrophysics and cosmology. Then he went to the University of Boulder and continued studies in nuclear physics. And Marc joined JPL, the Jet Propulsion Lab, in 1986, and he's worked on some of the most interesting projects there. Well, they're all amazing projects at JPL, but some of his works included detecting planets that orbit other stars, designing a mission to return samples from Mars, lasers, altimeters for Mars, infrared space telescopes, lasers, and all kinds of cool stuff. But more specifically, he led the Deep Space One mission, which was launched back in 1998, and it took NASA's first close-up picture of a comet. So Deep Space One, not to be mixed up with Deep Space Nine, the Star Trek series. Incidentally, Marc is a very big Star Trek fan, as I am. Another great accomplishment of Marc was his being the chief engineer, mission director, and project manager on the Dawn mission. And that goes back a few years. And Dawn was the mission that explored two uncharted worlds in the inner solar system, Dawn and Vesta. And they used the Ceres, excuse me, Ceres and Vesta, thank you. And the ion engine in the spacecraft has a very interesting story behind it and connected somehow to Star Trek. I talk a lot about Ceres in my classes, my space classes, as some of my students here will attest. And it's amazing actually how many students are interested in Ceres, and I found that quite amazing. Marc's received many awards and honors, including Exceptional Achievement Medals and 4 Outstanding Leadership Medals. And he's received the highest honor from JPL for extraordinary technical contributions made over an extended period. And when we're talking about these space missions, we're really talking about extended periods. These things can go from proposal to launch to mission completion. We're talking 20, 30 years. Would you say, Marc?
Can be, yeah.
It can be that long. Marc is a technical advisor and popular writer for NASA's educational website, The Space Place. And his hobbies include dancing, photography, hiking, and others. And he's also got a black belt in karate. And he's possibly the biggest Star Trek fan at the Jet Propulsion Lab. And before the meeting, I sent everyone the link to his amazing TED Talk. And I strongly encourage everyone, this week or whenever you have a chance, check out that video. It's a lot of fun. And if it's not worth, if it's not impossible, it's not worth trying. Is that the way it went, Marc?
If it isn't impossible, it isn't worth trying.
It's a great video. I've seen it many times, so I highly recommend it. So leave a comment for Marc on there. And again, welcome, Marc, and thanks very much for coming to helping us finish 2023 with great style and fun. And I know the kids are super excited from all over the world to interact with you. So I'll leave it to you maybe to say a word or two, and then we'll just dive into the Q&A.
Okay, well, I'll just begin by thanking you for inviting me. As I think Bruce told all of you, he and I are good friends. And part of it is because we enjoy talking with people like you so much, each one of you, students who are interested in space and science and exploring the universe. And that's something I've loved doing my whole life. And I became interested in space when I was 4 years old. And when I was 9, I decided I wanted to be a NASA scientist. It was a few more years before I actually managed to accomplish that. But I feel like I'm getting to live a dream come true. I am so lucky to be doing what I'm doing. And every single day, I realize that. And, the pictures that are around me in my background here, normally I like to tell people it's just the view out my window, but as you know, it isn't. These are all missions that I've worked on, and I've worked on others as well. But to me, it's just so fun. It's so cool. And so I'm really happy for the opportunity to share with you anything you're interested in, either about how I got here or what I've been doing or what I'm interested in, or anything you want to talk about. Under Bruce's guidance, I'll be more than happy to talk with you about.
Great. So maybe just a quick question to orient the students. You're in charge of multiple missions at JPR. You consult and help, but now you're in charge of a specific mission. How does that
Right.
work?
Well, so the specific mission I'm working on, Psyche, which actually happens to be right here, and here's an artist concept of what the Psyche is. So this is an artist concept of the asteroid. Here's the spacecraft, which is in space now. And I'd been advising the Psyche project for many years, but earlier this year, they asked if I would actually join the project to help them get ready for launch and begin the mission that is, once it gets in space, to go through all the work necessary to check out the spacecraft, make sure it's healthy in space, make sure it can do everything that it was designed and built to do, and get it on its way, because it has a long and difficult 6-year mission. Think of that. It's going to fly 6 years just to get from launch at Earth to its destination here. And then it's got to spend 2 more years taking pictures and making other measurements. And so I was lucky enough for them to ask me if I could help out and just make sure everything went smoothly. But I also do spend time on other missions as well. And to me, part of the fun is I get to be involved in many different missions. And I think every one of them is exciting and interesting and just plain cool. So that's part of what I enjoy doing.
Okay, wonderful. So yeah, you can raise your hands in the chat, or you can write your questions into the chat box. We've got one from Zavian. Sorry if I'm not pronouncing correctly your name. Did you find any other galaxies?
No, I personally have not found other galaxies, but also see the picture in the background here. Every single dot, every single one that looks like a star is a galaxy. And I put this graphic together myself because that background picture of other galaxies, I just think is incredibly cool. If you hold up a grain of rice, just a piece of rice at arm's length, that piece of rice is larger than everything that's in this picture. It's a tiny, tiny, tiny piece of the sky. And yet look at all these galaxies around here. It's amazing. the universe is filled with galaxies. We, of course, live in one galaxy. Maybe I should take a step back and be clear about what a galaxy is. A galaxy is a very large group of stars, and mostly stars, but also gas and dust and planets and other things. We live in the Milky Way galaxy that maybe you've heard of. And when you look up at the sky at night, unless you have very, very good vision and you're in a very dark sky, under a very dark sky, then everything you're seeing is part of the Milky Way galaxy. So everything that you see is part of it. And yet again, every one of these little dots is its own galaxy. It's pretty remarkable. So I haven't discovered one myself, but I certainly enjoy looking at them.
Wonderful. Mary would like to know, do planets make sounds?
Well, sure they make sounds. I live in Southern California near Los Angeles. And when there are earthquakes, I can hear it. So that's a sound. The oceans make sounds. They're part of our planet. The wind is part of our planet. And for that matter, I'm part of the planet. I'm making a sound. But planets do not make sounds that you would be able to hear if you're not on the planet. And the reason for that is sound is carried through the air. So the reason you can hear me is I make a sound, and what I'm doing is with the vocal folds in my neck, I'm vibrating the air. My microphone picks that up, carries it to your computer, and then your computer speaker vibrates the air again, and that vibration in the air goes to your ears, and that's how you hear. So the important part of that is the sound is carried by the air, but there is no air in space. And so we could make as much sound as we wanted here on Earth, but you wouldn't be able to hear it from another planet because there's no air in space to carry that sound. And I should say, Mary and others, if I give an answer you don't understand, tell me. Okay, if you don't understand it, it's not your fault. It's my fault for not explaining it well. And there's nothing ever wrong with saying, I don't get it. I don't understand. I don't know what you're talking about, Mark. So if any of these answers aren't helpful, put it in the chat, or otherwise let us know and I'll try to do better.
Okay, thanks for that. Juliano says, for how long have you been doing this?
Well, okay, so I'm very old. It's almost hard to conceive of how old I am. But I started working at JPL in 1986. So it's 37 years, 1 month, and 11 days. And I've loved every minute of it. It's so cool.
Further to that, Mark, how far do you go? And is there such a thing as retirement, or does that even exist in your vocabulary?
Well, it's not in my current vocabulary, but I do have a lot of other things I'm interested in. You mentioned some of them, photography and hiking and things, but I'm interested in writing a book. Now, Bruce here has already written books. He's ahead of me in that. I don't feel like I have time to write books while I'm working, but I already have in mind ideas for 3 books that I'd like to write sometime. So that may be something that I'll retire so I can find time to do.
Nice. Pavel asks, sorry.
Bishop has a question. I'm going to unmute you and have you try to ask the question, okay?
My question is, if you cannot hear things in space because there's no air, then how do astronauts communicate when they're like on the moon or something?
Okay, so just because the audio was a little distorted, I'll just make sure everybody heard the question, which is, I just said a few minutes ago, you can't hear in space. So asking, how do astronauts hear when they're in space? Is that a okay summary of the question? Or I'll trust that it is. And the way they hear is they have a helmet on that has air in it, or they're inside a spacecraft that has air in it. And so just like I described, I'm talking here, it's picked up by my computer microphone, then it goes through electricity and the world, the internet and the World Wide Web and all that stuff to your computer, and your speaker vibrates the air. The same thing happens for astronauts in space. They talk into a microphone, it gets turned into an electrical signal, but when it goes to another astronaut, it gets turned back into sound waves inside their helmet or their spacecraft. And again, the sound is the vibration of the air. Does that make sense?
All right.
I hope it does.
We muted him, so
Okay.
that's why. I think
Okay, well, I'll ask for your help again, though. If I'm giving answers that aren't clear, just tell me.
yeah, he said in the chat that is clear.
Okay, good.
All right. So we're gonna have Richard go next. I unmuted you, Richard. Go ahead.
What's your favorite mission you ever done?
Okay, well, so I love many missions, but my personal favorite is this one right here, Deep Space One. And it's also actually shown up here. It was unbelievably hard. I've never done anything in my life as hard as Deep Space One. Bruce told you earlier about this thing that we call a TED Talk. It's a video, it's short, it's only 16 minutes. And I talk about that mission there. But I love it so much because it was so stressful. I thought it was going to fail, and I was under pressure, just more intense pressure than anything I'd ever done in my life. And it was the first mission that I worked on from the very beginning, where all we knew about it was enough to couldn't even fill one sheet of paper with everything we knew about it. We just had a sort of a vague idea of what we wanted to do. I was with the mission from that point all the way through, fully designing it, building it, testing it, launching it, and controlling it on its journey through the solar system. And it was so exciting to be able to be involved in all different parts of it, and so rewarding when it succeeded, that I just thought it's the most exciting thing I've ever done. And if you watch the video, you'll see why. And it's okay if you've never heard of the mission. It's fine.
Well, that's why everyone should have a look at the TEDx video if you have a chance.
Yeah. And for some of you, there may be some things in it that you don't exactly understand, but your parents or teachers could clarify for you some of the things if I talk at a level that maybe doesn't exactly make sense to you, but maybe you'll enjoy it.
Okay, thanks, Mark. We have a question from Savish. Would you like to unmute, Savish?
You need to unmute them.
Okay.
I did.
Savish, go ahead.
I did this. Go ahead.
How fast can a rocket go?
Can you repeat that, please, Savish?
How fast can a rocket go?
How fast can what go?
Rocket, I think.
Oh, a rocket.
How fast
Did you
can a
say how
rocket
fast?
go?
How fast can a rocket go? Okay, so most rockets go between 17,000 miles per hour and about 25,000 miles per hour. So now let me clarify that. To go from Earth, the ground where you and I are, or at least that's where I am. I don't know where you are. Were you on Earth? Well, I'll just assume you're on Earth. Okay. So if you're on Earth, to go from the ground on Earth up into space to go into orbit around the Earth, you have to go a little more than 17,000 miles an hour. So astronauts on the space station are going that speed. When the space shuttle was flying, that's how fast it went. Somebody I see put in the chat, Mach 3 plus. Mach means the speed of sound. So Mach 1 is the speed of sound. Mach 2 is twice the speed of sound. Mach 10, say, is 10 times the speed of sound. So to go to Earth orbit, you go to about Mach 25 times the speed of sound. So most rockets go to about that speed, a little over 17,000 miles per hour. However, if you want to go farther away, you need to give the spacecraft a bigger push. You can think of it as throwing the satellite or the spacecraft faster so it can break free from Earth's gravity. And to do that, you have to go about 25,000 miles an hour. It's pretty fast.
25,000 miles. Quick conversion. How much is that in kilometers?
36,000, I think it is. 36,000 kilometers per hour. And another way to say it is, it's fast.
Awesome. Okay.
So we're gonna have Tommy go next. Go ahead, Tommy.
I have a yes. So how is like I know that one of the Voyager 1 or Voyager 2 went out of our galaxy. Do you know anything like about that? Like how one of those is doing outside of our galaxy?
So I do know because I'm actually working on the Voyager mission. In fact, I worked on it yesterday, today, and I'm going to work on it over the weekend, in fact. But let me first, and in fact, this spacecraft right here is Voyager.
Wow.
Yeah. You didn't know it was so close, did you? I can just reach out and touch it right there. But let me, before I tell you how it's doing, let me say it actually did not leave our galaxy.
Oh.
So again, our galaxy is just unbelievably large. Voyager left our solar system. So solar system is one star, which we call the sun, and the planets. Maybe you and some of the other people here know them, Mercury, Venus. Anybody know what the next planet is after Venus?
Venus. What's after Venus?
After Venus, it's Uranus.
No, good guess, but actually after Venus, it's Earth. So if you go outward from the sun, if this is the sun, the orbits of the planets are Mercury, Venus, Earth, and of course the moon orbits the Earth. Continue out farther from the sun, you get to the asteroid belt. There's a lot of things in the asteroid belt.
Ceres.
That's right, Ceres, which in fact is shown here because my spacecraft explored it, and Vesta, which is shown right there, which my spacecraft also explored. Then out past Ceres and Vesta and the rest of the asteroid belt is Jupiter. Oh, and I should have pointed out, here's Mars. I've also sent spacecraft to Mars. There's Jupiter, then Saturn, maybe one of the most beautiful planets, because of its rings. Then Uranus, then Neptune. That's the most distant planet. Oh, and somebody put it in the chat there, right? Then out past Neptune are many more smaller objects. That's the solar system. There are also comets. Here's a comet right here. This is a comet. That's our solar system. So Voyager, the two Voyager spacecraft, left the solar system. They will never, ever, ever, ever leave the galaxy. In fact, it would take tens of thousands of years just to travel the distance to another star. But they will never leave the galaxy. But it's still pretty amazing. Oh, go ahead.
Yeah, I'm pretty sure that the galaxy is like 100,000 light years long, the Milky Way.
You're right. That's so cool that you know that.
Hmm.
Do you know what a light year is?
How many, well, like how much of a year would take it to go like light speed, a year in light speed?
It's right. It's how far light goes in a year. So, for example, here's the Earth here. To go all the way around the Earth, think of everything you've ever seen, you know, not only where you live, where you go to school, but, you know, everything you know about on Earth, the mountains, the oceans, other countries. Earth is a big place, right? Earth is big. It would take light, or let me put it differently, light could go all the way around Earth 7 times in 1 second. It's pretty amazing. Light really goes fast. To get from the Earth to the moon takes astronauts more than 3 days. It takes light less than 1.5 seconds. So if you aim like a laser at the moon, it would take from now to now that time to go all the way to the moon. And even to get to the Voyager spacecraft, which are very far away, it takes about a day, roughly. But for light to cross our galaxy, it would take 100,000 years. The galaxy is big. But anyway, so the Voyager spacecraft are still in the galaxy, our galaxy, outside our solar system. They are healthy and returning scientific measurements to us all the time. And they've been flying in space for more than 46 years. They've been operating longer, I believe, longer than any other spacecraft. That's pretty cool.
It is cool. Actually, I visited the Voyager team back at the end of 2018 after our short visit at JPL, Mark.
Yeah.
And they're in this little strip mall outside of the JPL main area.
Well, they used to be. They moved back to JPL in the time since you've been there. But anyway, go ahead.
They brought them. No, it's good to know. I'm out of date. So they brought them back to the main campus.
Yeah, right.
Good. Well, I was surprised at how sort of humble their accommodations were at the time. So do they have a new mission control for them, a new setup?
Well, you know, most missions at JPL don't have the kind of mission control that we think of, you know, that like you see on TV and movies and on the web with rows of computers and men and women sitting at those computers. And the reason we don't do that for most of our missions, we don't do it for Voyager or for most other missions, because the spacecraft are so far away that you don't need to be sort of controlling it all the time. They're just too far. When we send a radio signal, so radio signals travel at the speed of light. So for these spacecraft pictured around here, it can take many minutes to hours for a radio signal to get from Earth out to the spacecraft. And so instead of having a bunch of men and women sitting at these computers, instead, we go to meetings, we are in conference rooms, we talk about what instructions we want to send to the spacecraft. We put those instructions together into a radio signal, essentially, that tells the spacecraft what to do over a period of hours or weeks. Because think if you had a joystick, or even if you think of typing on your keyboard and it taking an hour from the time you type until it shows up on your screen. That doesn't work. So we can't control it like that. So we have to send it all the instructions and let it carry them out over hours or days. And so we don't need people sitting there in these banks of computer stations.
Yeah.
So they don't have the kind of mission control that you're accustomed to thinking of.
Yeah. Very good. In the chat, a question from Pavel. What is your opinion of life on other planets?
Well, I guess my first opinion is it sounds like a great idea. I'd love to have life on other planets. We, of course, have never detected life on other planets. So I'm actually glad you asked my opinion. But let me first clarify. It's a scientific question. Is there life on other planets or is there not? And so whatever my opinion is, there's eventually a correct answer, right? It's like you could ask me what's 52 times 50. Doesn't matter what somebody's opinion on it is. There is a correct answer and an incorrect answer. Actually, there are a lot of incorrect answers to that. So just want to be clear, some questions sort of, our opinions are interesting, but in the end, the answer is whatever nature or the universe really is. So I hope that makes sense. But since we don't know yet, we've never been able to investigate other planets for life, we can, we can combine the scientific information that we have to make a prediction of whether we think there is life on other planets or not. Eventually, scientists will figure out the answer. And my prediction is that life will be found on other planets, because life is mostly very advanced chemistry. Maybe you haven't had chemistry in school, but you know about all different kinds of chemicals, right? Like water, alcohol, maybe you've heard of acid and bleach, and maybe you've heard of other kinds of chemicals. Oxygen is a chemical, nitrogen, helium, I'm sure you've heard of that. So life, what we're made of chemicals that have just combined in very special ways. But there's nothing about Earth and its environment that we know of that we have every reason to believe that the conditions on Earth that were responsible for life forming and then growing more complex into things like humans, there's every reason to believe those same conditions could occur elsewhere in the galaxy and in other galaxies. So I think eventually we will probably find life somewhere else.
Great. So we're going to have Juliana go next. Go ahead, Juliana.
For how long, have you ever gone on a spaceship and discover any new planets?
I missed a key word in there. Have I ever what a spaceship?
Have you ever went on to a spaceship?
Okay, yeah. So I have not gone on a spaceship myself. I've always wanted to. I wanted to be an astronaut, but my vision, my vision wasn't good enough. So I couldn't be an astronaut. But astronauts don't go to other planets. Astronauts can't discover other planets. Actually, if you're still unmuted, can you tell me where you live? What state or city?
I live in Peru.
Okay, Peru. It's a beautiful, gorgeous country. So I'm in California in the United States. You and I are much, much farther apart right now than astronauts are on the space station from Earth. So astronauts on the space station are only about 250 miles or 400 kilometers away from Earth. They're not very far away at all, not very far. So to go to other planets, you have to go millions of times farther than where astronauts go. And again, I know I haven't answered your question yet. I will. I tend to give long, wordy answers. I hope you're all patient with that. But I want to say that some of my spacecraft, like these, have gone to more than 1 million times farther away than astronauts on the space station, and more than 1,000 times farther away than the moon. So astronauts have never gone farther than the moon. In your lifetime, they may never go farther than the moon. But even if they do, I guarantee you, they will never go far enough away to discover other planets. Astronauts do not go far away. And that's why these kind of spacecraft that don't have people in them are so cool, because they can go farther away. And so I have never discovered another planet, but we have built spacecraft that in space and telescopes on the ground that have discovered thousands of other planets around other stars. And one of the things that I think is going to be so exciting in the coming few years. So while you're still, before you graduate from high school, maybe we will be able to get pictures of some of these other planets and make other scientific measurements that will help us understand more about their nature. You know, do they have oceans? Do they have atmospheres? Maybe even, do they have life? And scientists are working very, very hard to answer questions like that on these other planets.
Great. All right. I know we have more students raise your hand. We especially want to encourage those who have not asked questions to raise your hand if you have questions. But before we do that, we love to know a bit more about, like, Marc, your experiences growing up, because a lot of the kids are very young, and I'm sure that many of them want to work at NASA after you grow up. Maybe after they grow up, maybe you can tell us a little bit more about what it's like for you growing up, learning about science. How did you discover your passion? And once you did that, what did you do to learn more about it? Oh, somehow we cannot hear you anymore. Marc, I think you might be muted. Okay, hold on. We try to unmute you. Hold on.
Thank you. I apologize. I was coughing, so I muted myself so you wouldn't hear my cough, and then I couldn't unmute. Okay. So I apologize for that. So you were asking me to talk about how I became interested in space. Is that right?
Yes. And then once you become interested, what did you do to keep building your knowledge?
Yeah. Okay. Well, when I was very young, like 4 years old, I was afraid, not afraid, I was terrified of witches. You know, like witches that fly on their broomsticks. You know, if you've seen Harry Potter or Wizard of Oz or other movies, I think everybody knows what a witch is. I was really scared of them, really scared. So I lived in Toledo, Ohio, just one of the states in the United States, and was outside one night when I was 4 years old with my parents and my older brother, and I saw a streak of light go through the sky. And I was always a pretty logical, scientifically minded youngster, so came to the logical conclusion it must be a witch flying through the night, flying through the sky on her broomstick. And I was really, really scared. I remember turning to my mom and putting my arms around her legs, I was really terrified. But they told me that it was a shooting star. That's how my parents described it. You know, when they say a shooting star, maybe you've heard that term, but really it's a meteor. It's something from outer space burning up in the atmosphere because it travels from outer space. Remember, we said there's no air in space, but when it gets close enough to Earth and it gets to our atmosphere, it goes so fast that it burns up and lights up the sky. And when they told me that it was something from outer space burning up in the atmosphere, I thought that was really amazing to realize it's not a scary witch. Instead, it's a piece of, you know, it's a rock from some distant place in the solar system. And that's how I became interested, excuse me, in space. So I was 4 years old then. I mentioned earlier, by the time I was 9 years old, I had been already going to the library to get magazines and books about space. And I decided I wanted to become a scientist eventually and work for NASA. And I mean, I love things like, you know, I like to play outdoors and hike and do things like that. But I found something I loved even more, and that was reading. And so I got a lot of books about astronomy, about space missions, about all different kinds of science. A particular branch of science that I'm very interested in is called physics. Maybe you've heard of it, maybe you haven't, and it's fine if you haven't. But physics and astronomy, but also chemistry, biology. I love to read about all these things. There's so much to learn. And so before I started reading, my parents were always worried about me that I didn't read enough. And by the time I was in the 6th grade, they were worried about me that I didn't go outside to play enough because I was spending too much time reading. I think eventually I found maybe kind of the right balance. But I started writing to, we didn't have email or Zoom for that matter, when I was younger, but I sent letters to JPL, where I now work, as well as other NASA organizations, to scientists at universities around the United States and around the world. I wrote to countries all over the world to learn about what they were doing and to ask them my questions. There was nobody in my small town of Toledo, Ohio, who could answer things I wanted. So if I couldn't find it in the library, I'd write them a letter and ask questions. And but of course, I also asked my teachers. I took all the math and science classes I could, as well as other courses. I loved trying to learn French and learn about history and other things as well. Then when it came time to go to college, I chose a university where I could learn a lot more math and astronomy and physics, as well as other things. And did that for 4 years to get what's called a bachelor's degree. And then I wanted to continue with my education because I love learning so much. And I actually stayed in school. Here's a shocker for you. I didn't finish school till I was 29 years old. Hard to imagine being that old, isn't it? But I stayed in school until I was 29, and I just loved learning all that time. And then when I was finished with school, I sent letters to all of the different NASA facilities. You know, there are 10 different NASA facilities around the country. And I got a job at the one I think is the coolest, JPL, but they're all really neat. And I've just been having a great time ever since.
That's awesome. We're going to go back to a student that have raised a hand in a minute, but I'm going to ask you another question, Mark, which is,
Sure.
You know, when people think of NASA, they think about math, you know, people who like math and physics and science and all that. Well,
Right.
if someone is not like don't consider themselves as a math genius, or they may just prefer reading and art and things like that, do you think there might be opportunity for them to work in NASA as well?
Absolutely. There's no doubt about it. NASA has and will always continue to need people with knowledge covering just about everything. Of course, as you know, math, science, physics, engineering, all that, of course. But NASA needs people with many different areas of interest and talent and skill. So why is that? Well, first of all, NASA spends money that comes from the government, but that money from the government comes from taxpayers. If you live in the United States or wherever you live, your parents pay tax to the government. That's how the government has money to do all of the work it does for the benefit of the people in the country. That costs money. And some of that money goes into the exploration of space through NASA. But that means NASA has to be very responsible in how it spends the money. So we need people, we need lawyers, we need business people, that is, people who understand how to spend NASA's money wisely. So in the business world, if one company wants to buy something from another, they may have a contract which makes sure they do everything legally and safely and responsibly. So I'm getting a little caught up in that. So we need people with business knowledge, legal knowledge. We need people with artistic talent in order to help the rest of the world visualize what we're doing. I mean, look, this I told you at the beginning. This is an artist's view of the asteroid Psyche. We've never been there. We don't know what it looks like. So a scientist and an artist work together, because scientists can say, well, maybe it should have this shape, it should have this color, it should have these characteristics. But scientists aren't good at then creating something that looks like that. The artist can make that, but the artist doesn't know what it should look like. So the artist and the scientist work together to do that sort of thing. We also need people who like to use language, who are good at writing or speaking, so that when at NASA we do something exciting, we have people whose job it is to write it up and express it in ways that the public, you know, people like you can understand, because often scientists are not very good at expressing their work and, you know, and finding words that are very clear so that other people can understand it. So we have many professional writers who can write it up in a way that then it can go to the outside world. So we need talent. We also, NASA facilities are big. We have our own police department, our own fire department. We have doctors and nurses. We have people who cut the grass, who manage, you know, maintain the trees, who make sure the plumbing works, the electricity works, the telephone system works, all the computers work. So a NASA facility is like a small town. We need everybody's talent to make it work.
Awesome. That's great to hear. It's like a really large community and, you know, like a small world by itself as well.
Yeah.
All right, so we're going to go back to the student. I'm going to ask people who haven't asked questions before first. Is that Dianesh? Dianesh, can you hear us?
Yeah.
Go
So
ahead.
my question, wait, let me just find my question. I kind of forgot it.
That's okay. I'm going to ask maybe Nazar, Nazar. Okay, I'm gonna try.
I'll just pipe in very, very quickly while we're waiting for the question. I remember, Mark, we talked about one of the human resources officers at JBL, Costa Rican lady, and she's the people that the ones that pay you and train you and give
Yeah.
you vacations and
Right.
and all that. Human resources, that's like the back office that hires people, fires people, trains them. And I begged her to do a web conference at some point. She says, no. I was like, please. And I remember in another conference, you talked for 10 minutes about her. I was very grateful for you.
Yeah, it takes all kinds of people with all kinds of interests and talents and skills. And you get to see people like me talking about stuff like this, but it takes many, many people to make it work. And many of those people didn't go to college. Most of them did, but some of them didn't even. So it's what it requires is people who are dedicated to doing some job successfully, to making things work. That's what we need.
All right, so Nazar, I think you are unmuted.
When did space get born?
Did you say, when did space get born?
Yes.
Well, so by space, I would say that's everything, the whole universe. Is that a fair way to change your question? When did the universe get born?
Yeah.
Okay. 13.8 billion years ago. So maybe you don't even know what a billion is. But if you wrote it down, it would be 13. So you know what 13,000 is, maybe? A 1, a 3, and then 3 zeros. That's 13,000. If you add 3 more zeros at the end, that's 13 million. Then if you add another 3 zeros onto that, that's 13 billion. So a little more than 13 billion years ago is when our universe started. And in that time, all the stars, all the planets, all the galaxies, everything we know formed. It's pretty long time.
Thank you.
Earth, I was just going to add one more thing. Earth itself, right here, only formed 4.6 billion years ago. So the universe had been around for 9 billion years before Earth formed.
Okay, I guess we're going to have time for about 2 more questions. Hopefully, someone who hasn't spoken yet, but there were a couple of great ones in the chat that we didn't get to, and I believe one was from Mary, and there was one. Okay, it was something about the next big thing in space science, and then also Chelsea says, I hope to work as an astrophysicist. What would be your top tips for someone pursuing that career?
Okay, so to be an astrophysicist, so for other people, if you don't know the term astrophysicist, it's like an astronomer. So to be a professional working astrophysicist, you'll need to learn a lot of math and other science in school up through the end of, or was this somebody in the United States, do we think?
Yeah, I think so.
Okay.
I think so.
In most countries, schools go to about the 12th grade, approximately. Sometimes it goes a year more or less. So you need to go all the way through the end of the 12th grade, senior year, graduate from high school, then go to college for another 4 years. And in college, you'll need to learn still more math and more science, that is physics and astronomy. And then after that, at the end of that 4 years, you get what in the United States is called a bachelor's degree. You don't have to be a bachelor. Don't worry about it. That's not what it means. It's a different use of the word. But then to be a working astrophysicist, you'll need to go on for still more school. I mentioned that after I finished my first 4 years of college, I continued on for school. To continue to study, you need to get a master's degree, and then what's usually called either a PhD or a doctorate. And that's what I did. I didn't finish till I was 29. And when you're doing that, you will continue to take classes all along until sometime when you're in your mid-20s. And then you have to do more than just do all the classes. You have to start working as a scientist, as an astrophysicist, and actually do real scientific work. And then you write it up in what's called a thesis. And these are extensive. I mean, my what's called doctoral thesis that I wrote was hundreds of pages long. And if you do all of that, then you finish school, then you become Dr. So-and-so, like I'm Dr. Marc Rayman, meaning I did all that schooling. And then you can get a job as an astrophysicist. It's long, it's hard, and it is just unbelievably fun. Because what could be cooler than learning about the universe?
That was from Chelsea. Thanks
Chelsea,
for that.
I don't get to do that.
Chelsea was down in New Mexico. We were talking about Area 49, or was it Area 51?
Yeah. And I see what Chelsea wrote. I'm going to be doing this for a while, but you're right. It's going to be worth it, because while you're doing it, you're learning. I mean, you're just constantly learning exciting new things.
Great one to maybe wrap up with. Sorry if I don't pronounce his name correctly. Juan Fu Pham asks, are there any missions that are focused on addressing and finding answers to the harm we are causing on planet Earth?
Yes, I'm glad you asked that. There are many missions dedicated to that. Excuse me. So I've been talking here, and showing pictures of spacecraft like this one leaving Earth and going elsewhere. But JPL, where I work, and other NASA facilities and many other countries around the world, excuse me, send satellites up to look back down on Earth to measure the harm that we're doing to the land, to the water, and to the air, because we're damaging all of them. And they make detailed measurements to help us understand the extent of to help us understand how much damage we're doing, what kinds of damage we're doing, and to try to help governments find ways to stop, to do several things, to stop the damage and to repair the damage, right? Because we're doing more damage every single day. So we have to stop doing that and then try to undo, or again, repair the damage that's already been done. And so much of that is helped by having satellites up above that can look down to try to, not to try to, but to help us with that. But yeah, it's not just scientists who have to solve these problems, right? We need governments to spend some of their money on fixing these problems.